Um, I posted this worksheet on the SI resources in Moodle. It looks like people here have gotten the extra copies that I had. I put these first true-false questions on here because I saw that on a previous year he had put some true-false questions on an exam, so I thought we should practice them. He's usually pretty predictable. I have seen that, you know, the tests that he gives year, like I said, I've been doing this since, however, the Dark Ages, and he's not always the one who teaches it, but he's taught it a lot. And the tests he gives one year are very similar to the tests he gives the next year. The problem is I haven't seen very many final exams because for the most part, those are taken and turned in and I don't really get to see them. So I've only seen one or two, but some of this stuff used to be covered on test 3 back when it was 2740, so I know what kind of questions he put on there, and so it should be fairly similar. So I have these 10 true-false questions here about sequential circuits and finite state machines. And what I'd like everyone to do, if you have not already done so, is spend a couple minutes just looking at these, talking with each other, coming up with what you think the answer is, because then it'll mean more when we go through them together. So if you haven't already done so, go through, look at these, and see if you think that they're true or false. And discuss with your friends or put something in the chat, or I don't know, just do them. Combinational. So what we're talking about with sequential circuits, meaning it has flip-flops. So all the stuff that you've been doing this semester with the finite state machines and things where the current state depends on previous state, that's sequential. Okay, well, I was really hoping to generate discussion, but most of the discussion I'm hearing is I have no clue, except I heard you say something that was correct, so I'm just going to go ahead and talk about these. I did want to generate discussion, so I would like you to chime in if you have a question about what I'm saying or a comment, or if you think I'm wrong. Okay, so number one, in a sequential circuit, does anybody have their camera on? No. Okay. In a sequential circuit, the output is determined only by the current inputs and not by any past inputs or states. Okay, that one is a definite false, because the whole point of flip-flops when you learn them is that they have memory. The input, the output definitely can depend on what the previous state was. So like for instance, a T flip-flop, is, if the input is 1, it toggles. Well, what does that mean? It means it can be the opposite of what it was before. So it has to know what it was before. So in a sequential circuit, the output is determined by both current inputs and past inputs or states. Now that's not necessarily true for every sequential circuit, but just in general it can be true. Okay, now get back to draw. Okay, a Moore machine defines its outputs based only on its current state, irrespective of input. I suspect y'all probably do know this one. You know the difference between Moore and Mealy, even if you don't know entirely what it means, right? Is this one true or false? This one's true, so you did in fact know it. So this one's true. A Moore machine, the output depends only on what state it's in, not the inputs. Number 3, Mealy machines can react faster to inputs as their outputs can change as soon as the input changes without waiting for a clock edge. So for this one, I want you to think about your final project. And if you did it at all like I did it, I had several always blocks. And one of the always blocks set the outputs, and one of the always blocks set the next state, and one of the always blocks advanced the clock. The one that did the outputs, the way I did it, if you looked at the videos or if you kind of followed my design, was that one on a clock edge? No. Oh, okay. All right. Yeah. Okay. Good. So people who followed my design actually did look at it. So it was not on a clock edge. So the outputs could change without waiting for the clock's edge. And so since Amelie, it's only going to change states on the clock edge, but the outputs could change before you get to a clock edge. So it can react faster to inputs. So that's going to be true. Every finite state machine can be implemented as a sequential circuit, but not every sequential circuit is a finite state machine. What do y'all think about that one? Yeah, that one's going to be true. Because just because it's made as a sequential circuit doesn't mean it has the characteristics of a finite state machine, which I'm not exactly sure I'd have a good definition for that, but I'd know one when I see one. State minimization in a finite state machine design is a process that reduces the number of states in the machine without changing the language it recognizes. You could change that to without changing its function, without changing the basic idea of the inputs and outputs. Is that one true or false?
True.
Yeah, that one's true. In digital logic, a flip-flop is a device used primarily for storing single bits of binary data and has no impact on the control flow in sequential circuits.
False.
That one is false. And why is that one false? Yeah, it can control the flow. So it's like, if you have a flip-flop, it can say what the next thing is that's going to happen. And so it does control it because it has logic in it as well. Asynchronous sequential circuits do not require a clock signal to function, unlike synchronous sequential circuits. You never really made any of these, but they do exist. And so, yes, it's true. Asynchronous don't operate on the clock edge. A state diagram and a state table contain the same information about a finite state machine, just presented differently. And I would say, when I say state table here, I mean the first one that just has the letters in it, not the one where you do the state assigned table where you start assigning bits to it, numbers. So this is just the one, your first draft that just has the letters. Would you say that one has the same information about the state diagram and the state table? They do. Yeah, they do. It's just kind of presented it a different way. A sequential circuit can be converted into a combinational circuit by removing its memory elements. So if you take the flip-flops out,
I feel like no.
yeah, I don't, no, no. In synchronous sequential circuits, changes to the output occur at, or maybe this should say changes to the state, occur at discrete intervals marked by edges of the clock signal. Yeah, usually you have them done at a clock edge. I mean, it's not a very good true-false question because you say, well, always, it's not, but this is just to get a general idea. Okay, so any questions on these concepts before we go on to start working some project problems?
What's like the characteristics for the finite state machine compared to just the sequential circuit?
Let's look up. Finite state machine. 333. Where's the page numbers? Okay, so sequential circuit. The outputs depend on the past behavior of the circuit as well as the present value of the inputs. So that's our definition of sequential circuit, that the outputs depend on past behavior as well as present values of the inputs. So that is a sequential circuit. Whereas a finite state machine, well, this would appear that my true-false question was wrong, but I still like it. Okay, so sequential circuits are also called finite state machines, which is a more formal name that is often found in technical literature. The name derives from the fact that the functional behavior of these circuits can be represented using a finite number of states. And so I guess the way I was thinking about it is a finite state machine, you model it with these particular states. And so you're talking about going from state to state. And that's what I was thinking of as a finite state machine, whereas a sequential circuit, I was thinking of just as anything using flip-flops. Your textbook is seeming to say that they actually are the same thing, so I would just ignore that true-false question and say, well, that was just my SI. She doesn't know what she's talking about, so I just leave that one out. So, since that's what the textbook says. So I would go with that over me, because I can't write a textbook on digital logic. Okay, other questions? I'm glad you asked that one. Anything in chat? Does not look like it. All right. I'll do one more problem and then I'll stop and record. Or stop. Oh, did I remember to start recording? I did. Okay. All right. So now going on to problem 1. We need to construct the state diagram of a Moore-type sequential circuit with input D and output G that behaves in the following manner. When the input sequence is 0, 1, 0, 1 on the 4 preceding clock cycles, then on the next clock cycle, output G is 1, otherwise G is 0. So can you tell right away whether this is Moore or Mealy? So next clock cycle gives us the clue that this is a Moore machine. If it's on the same clock cycle that you received the previous input, that would be a Mealy machine. I could see that being a kind of question that he would ask, like as a true-false sort of thing. So you want to look out for that. So we want to think about what our different states could be, and you always want to think about them as heading towards your goal of getting 0, 1, 0, 1. So we'll have our reset. And the reset is going to be also equivalent to having just a 1 without having a 0 before it. Because if you have just a 1, that's not getting you anywhere towards the 0, 1, 0, 1. So reset or just a 1. And then if you get a 0, then you're on your way towards having your 4-bit sequence here. And so that would be a state. So I'll put that one in. And I'll put the output on the state since it's a Moore machine. So G equals 0. We won't get G equals 1 until we actually get our sequence. So we have two possibilities here. One is if the input D equals 0, Then we'll go to this state that I'm just going to temporarily call 0. And G will also equal 0 because I don't have my sequence yet. So what happens if I'm in my initial state and I get an input of 1? It goes back because I still don't have anything. So this would be D equals 1. Okay, now if I'm in state 0 and I get another 0, well, I haven't advanced any, but I still have my 0, so I can stay where I am. I still have 1, 0. But if I get a 1, then I'm making progress towards my goal here. And now I have 0, 1. My output is still going to be 0. So if I have 0, 1 and I get a 1, I've now ruined everything because now I don't have any, I can't get 0, 1, 0, 1. So if I get a 1, I have to go all the way back to the beginning. But if I get a 0, then I'm at the next step. I've now got 3 bits towards the output that I'm trying to get. So I now have a 0, 1, 0. And this would be if my input was 0. And my output is still going to be 0. If I get another 0, so if I have 0, 1, 0 and I get another 0, what state am I in? Not the same one, the second one. Because all I have now is a single 0 towards my goal. Because if I want to get a 0, 1, 0, 1 on my last 4 bits, then I can only use this 0 right here because there's no sequence of 2 zeros in here. I can only use that first 0. So if I get a 0, I go back here. Now what if I get a 1, 0, 1, 0, 1? I'll be here. And that does need to be a separate state because I don't output my 1 until the next clock cycle. So this is D equals 1. So if I'm at this state, now I have my output of 1. What happens if I get a 0? It goes right back to the one before. You ever look at this like, what is that? Yeah, so if I get a 0, I go back to the one before because now I've got 0, 1, 0. So I'm all posed to get my next one. I could come right back here and get my output of 1 again. What if I get a 1 though? All the way back to reset. And that would be your state diagram. Usually, I usually label my states. I like having the little descriptive labels that tell me what each one does. Usually when you put them into a state table, you use letters for them. But as long as you're really clear and you're not saying that something like this is an output, then I think it's clear what's going on. All right, any questions on that one? Okay, I am going to stop this recording and save it and start a new one.